Welcome everyone to another Tech90. Today you got myself, Greg Brunts. I am the National Technical Support Specialist for Tradewinds, basically GREE. And we also have Jesus. Jesus, say hi to everybody.
Hello everyone, Jesus Fraga here, Commercial Inside Sales Engineer for the VRF product. Welcome back to another show.
All right, today we got another, we're going to be talking about MultiPRO startup, troubleshooting, and piping overview. So, I mean, that was the title I had into it. I'll just kind of give you a little bit more of a heads up. So we're gonna have Jesus doing a walking through our quick start guide, which is new for the R32 MultiPRO. And then we're gonna follow up with that with a clip from some recent training that I've done with 410A product. But just so you know, the service tool I'm using in that whole training is the same service tool you'll be using for R32 because the pressure temperature differentials and stuff like that is based off the board program, not off the tool. So it's just reading what the board is telling it. So that's a good, make sure I want to get that out and let everybody know that no, since we're going to MultiPRO R32 equipment, you don't have to go out and get a new service tool. The service tool you already own, if you have one, is already capable of doing the MultiPRO R32. So if you haven't attended Tech90 in the past, like I said, we're going to do a review of the quick start for VAR32. After that, we'll come back and chat with you live and answer questions up to that point. Then we'll continue with another section. Like I said, we're going to talk about MultiPRO. And I got some multi-zone piping in there, kind of showing you the difference between the two. I think you'll enjoy that and get a better understanding of refrigerant flow with these systems. So the whole point of all that is if you don't understand how they're supposed to work, then it's pretty hard to troubleshoot them. So that was the way I was taught in trade school. You got to know how it's supposed to work in order to know how to fix it, right? So anyway, we encourage you to get in the conversation. As a reminder, if you have questions or comments at any time during this broadcast, use the question mark icon to the right of your screen and send them our way. We'll answer any relevant questions until we run out of time. All right, so with that, let's get started. Let's go ahead and let Jesus talk to the quick start.
Hello everyone, my name is Jesus Fraga. I'm Commercial Sales Engineer for the VRF product. And today I'm going to go through the quick start guide for the R32 products, specifically MultiPRO. So first off, I'm going to show you guys how to get to the actual quick start guide. If you go to greecomfortac.com, hover under products, you go down and you'll see a MultiPRO R14A and a MultiPRO R32. We know 14A is the old, R32 is the new. So we're going to go ahead and click on MultiPRO R32. We'll see here it opens up the outdoor unit. You scroll down a little bit. We have our indoor unit selections. Keep scrolling. Then we'll see a taskbar here, and we're just going to go ahead and open it. Go ahead and click all. Once you click all, you'll see all the available documents for the outdoor unit, for the R32 outdoor unit. And so we have the service manual, the quick start guide, the parts manual, and all the submittals. So what we want to do today is do the quick start guide. MultiPRO R32 quick start guide. Start off here. As we see, some things change and some things stay the same. So in MultiPRO R32, we know that we have a communication data chain that goes to the indoor units. We still have our line voltage power. And to compare that to multi-zone mini splits, we know that multi-zone mini splits is 14.4 communication wire and power. So that means that this wire here has 4 conductors. One's used for communication, the other is used for ground, and the other 2 are for power. The main difference here is pretty much the communication method that is used. One will use the 14.4 as I stated, and another will use the 18.2 stranded communication wire. Now with R32 MultiPRO, there's an added feature where you can actually power the indoor units via a terminal block at the outdoor unit. And we'll see that on the next page below. To clear some other information here on this page, we recommend that you have service disconnects at each indoor unit. Those units are going to be units that do not utilize heat kits. The reason for that is because the amperage that the heat kit will produce will not be capable of the wire that is supplied from the outdoor unit. There's an exception to this, and as I stated earlier, we'll see on the next page what I'm referencing to. The communication wire is 18.2 stranded wire. Does not have to be shielded, just stranded. And the indoor connected capacity requirement is the same as the 14A model. So you have to have a minimum of 50% and a maximum of 135. If you fall out of that window, the unit will not start and give you an error code. Depending on if you're low or if you're high, will be the error code that you see. So continuing on here to the next page, this is what I was talking about, the capability of the outdoor unit being able to actually power up the indoor units. And there's a lot of information here that you'll need to follow when you want to utilize this XT3 terminal block. This XT3 terminal block is the one that is going to carry the power to the indoor units. And if this is utilized, as we see here on the nameplate, you will have to follow the MOP for utilizing the outdoor terminal block XT3. So that is of 60 amps. As we see here, we got MOP, ODU only, 40 amps. And other devices means the indoor units, it's 60 amps. Emergency power is 15 amps. We will talk about emergency power later on in this quick start guide. So, as I had stated earlier, for the units that are utilizing heat kits, this will not be applicable to those units as the heat kits do pull more amperage, and the wire that is supplied from the outdoor unit to the indoor units, it will not be able to support that heat kit once it is engaged. So if any of the indoor units do have heat kits, as I stated, please utilize and please use a dedicated line of power from the panel. That way you don't run into any problems with inspectors. The emergency power MOP is 15 amps, MCA is 1, and it will only be used when required by local code. It is used to isolate the refrigerant in the outdoor unit when there is a power loss to the outdoor unit, or could be used with a fire alarm panel in a commercial application. So that was having to do with emergency power. It's not needed in every application, but the main time that you would use that is in pretty much in commercial. And we have supplied a wiring diagram here that is out of the service manual that explains exactly where those terminal blocks are sitting in the unit. And here's a reference photo of a GMV6 R32 3-ton unit. So the communication wire, nothing really changes on this side of it. You know, we're still going to run our 18.2 from the outdoor unit. It's going to be D1 and D2 in the ground. So we know that we have D1 and D2 from the outdoor unit, goes to the first indoor unit. From the first indoor unit, it goes to the second indoor unit, and so on and so forth. And the last unit in line is going to receive the 1/4 watt, 120 ohm resistor that comes with the outdoor unit. And so what you can do is you can place that across D1 and D2. That way you don't have any type of communication errors or communication faults when the system actually starts up. And so you'll notice this grounded wire here. You know, we have a splice in the first unit, splice in the second unit, and we're going to go ahead and terminate at the last unit. Now, this doesn't mean that we're going to land these wires in the middle of the communication method. So splicing, we know we're going to grab the ground going to the next unit and the ground coming from the next unit and pretty much splice it together here, splice it together here, and only terminate at the last point of contact in that data chain. And so this gives one path of interference, if there ever is any, in this communication data chain. So that means if there's some type of communication fault here or a ground, it'll travel its way out to the outdoor unit and terminate there, and not in between the data chain communication. So going on. So for auto addressing, it's a lot similar to the 14A models. The indoor units will auto address, randomly selecting the main indoor unit. Main indoor units can be changed, use the wired controller or wireless remote. So what this means is you can actually go into the wired controller, before you actually go through the commissioning and designate what address you want for what area. That way, if you're mapping out a site, you know you can do that with ease instead of it doing it randomly. But an added feature and something that I always mention is that it'll do it automatically. So there's no need to manually do this. You can do it for mapping out purposes, but it's not necessary. And so we go on here with the addressing again. So the setting of main indoor unit, as I stated, you can go to the wired controller that you choose to be the main indoor unit and actually designate that system for main indoor unit operation. What this means is this main indoor unit will be able to change, will be the only unit that will be able to change the mode from heating to cooling and vice versa. If you try to go to any other controller in the system, you will not be able to do that. You'll just get, actually, you won't even get the selection of the opposite mode that the unit is in the subordinate controllers. And so here's more information on how to do that. You set the mode to fan, set temperature 86 or 30 degrees Celsius, press up and down 3 times quickly. UC will display on the indoor unit. This sets the unit to be the main unit. This applies to wireless controllers. Moving on now to the control wiring. Our ductless systems, they come with a remote controller, but they do have the possibility and the option for controller to be connected to the system. This is via H1 and H2. For example, here we have a wall-mounted unit. We have D1 and D2, which is coming from an outdoor condenser. And we also have another set of pins here, H1 and H2, which we know that that's our wired controller. So we open up this case and we'll see this terminal block there next to the line voltage terminal block. Another key feature here is if you wanted to control multiple units using one wired controller, you can also do this via daisy chaining the thermostat terminal block H1 and H2 via indoor unit to indoor unit to indoor unit. Depending on how many indoor units you have and you want this wired controller to control is how long your daisy chain, excuse me. Please remember that the wired controllers are only capable of doing up to 16 indoor units via one controller. So just keep that in mind. So in our new R32 wall-mounted unit, a Molex plug was actually included by the factory for installation out in the field. Me being in technical service and technical support, I always got the question of how am I supposed to wire this Molex plug up? This is the before picture here. The factory has actually supplied a Molex plug that actually connects to here, and now you have access to be able to easily connect a wired controller via H1 and H2 via this harness. This is on wall-mounted units. So moving on to central control and co-automation, wiring and address setup. As I stated earlier on the previous slides, a lot of this information stays the same, so same applies here. The note here is this only applies if there's more than one condenser that will have a central controller or has co-automation. So if we have, for instance, 16 systems in line here, addressing strategy is pretty simple. So as we see here, we know that this is always going to be this first system. So because all the dip switches are actually in the off position. And once we go to the next system, we flip the first, we flip the second, so on and so forth. And we'll see that in the chart that we have on the next page for you guys. A quick note here is make sure that G1 and G2 are wired and daisy chain between the outdoor units. Set the dip switches on outdoor units. This should be done before the startup. Even a central control or co-automation is not being connected until a later date. If you try to do this after the fact, you will have addressing conflicts and all sorts of other issues, and the system will give you the error codes pertaining to that fault. Going on forward here, this is the chart that I was referencing. So we know that system 1 is going to have all the dip switches in the off position. System 2 will have dip switch 1 in the on position. System 3 will have dip switch 2. System 4, 1 and 2, and so on and so forth. Depending on the unit that's in line in your daisy chain. So as a note, as I stated earlier, please do this before startup, even if central control or co-automation is not being connected until later. This will save you a lot of headache whenever you do try to add those additional controls. All right, moving on. Refrigerant piping installation guidelines and descriptions. This heat pump has two pipes, liquid and a gas. Both must be insulated. System mode is set by the user to determine main indoor unit, or is selected randomly by the system if you do a automatic addressing. A lot of these same things apply, so we know that 20 inches must be maintained between elbows, headers, and Y branches. And here's an explanation or an example on how those Y branches are actually laid out. Moving on. Y brancher and header installation. This is very important when it comes to installation to avoid things like compressor failures, inadequate cooling, increased energy bills, energy consumption. These installations of the Y branches and the headers are crucial. So as we know, they're specifically designed for even distribution of refrigerant. Each kit includes one Y branch for gas and one Y branch for liquid. Simply use a tubing cutter for larger line sets. If installed horizontally, they must be level. If installed vertically, they must be plumb. FQ01AA is used for downstream capacities of less than 68,000 BTUs. FQ01BA is used for downstream capacities of more than 68,000 BTUs. So a good way to look at this is typically you'll see this FQ01AA used for all the MultiPRO single phase equipment. FQ01BA is used for mainly commercial. Typically that's where you'll see it in the commercial applications is when this will come into effect. So moving on to headers, they are specifically designed for even distribution of refrigerant and oil. Each kit includes one header for gas and one header for liquid. And same thing as the Y branches, simply use a tubing cutter for larger line sets. Must be installed horizontally and they must be level. Liquid header is built with downward facing offset for installation next to gas header, as we illustrated here in this picture. So this is the L shape of the liquid line, and the gas will sit on top of it if you choose to install it that way. As long as they're horizontal, you don't have to necessarily do this, but you know that they are designed to fit right on top of one another. So we have the FQ14/H1, and we know that that one's our 4-port header. FQ18/H1, that's our 8-port header. Moving on here. This is our single zone piping limitations. So it gives us, this chart pretty much gives us the max length ODU to IDU, the max height ODU above IDU, max height ODU below IDU, and we know those values are 213, 164, and 131 feet. So one of the key differences between the 410A and the R32 is the line set connections at the outdoor unit. For the R32 MultiPRO unit, all the line set sizes are 3/8 by 5/8. That's 3/8 liquid, 5/8 gas. And if it's necessary, please reduce the piping size at the indoor unit. So below is an illustration of a 1-to-1 and how to centrally locate that unit. So our dual and multi-zone MultiPRO. So here goes some more values of maximum piping lengths for the MultiPRO R32. So we have a max length of ODU to Y branch. We know that's 98 feet. Max length IDU to Y branch or header is 50 feet. Max height ODU above IDU is 98 feet. And max height ODU below IDU is 98 feet. So below is a basic limitation. Actual limitations are far greater. Use MultiPRO System Builder, MultiPRO Selector, or see installation manuals for more details. That's what I always like to mention, that we actually have the software on our GREE commercial site. It's a VRF selector. You can actually download it. It's free. and you punch in your outdoor units, your indoor units, and your copper links, and it'll actually give you the if it actually accepts the design and the additional refrigerant charge as necessary for your application. So, moving on here, dual and multi-zone MultiPRO. So as we stated earlier, these are the line set connections for the outdoor units. We know they're all 3/8, 5/8, so no confusion there. This changes from the 410A models as 5 through 12K stay 1/4 inch to 3/8 line set connections for the indoor units, where before 3/8 would take us up to or down to 9,000 BTUs, and it would change at 12,000 BTUs to 1/2 inch. So now we have 5 through 12 will be 1/4 to 3/8 gas and liquid, and 14 through 24 will be 1/4 half gas liquid. 30 to 60 is 3/8 5/8 gas and liquid. And so below is an example of a multi-zone with a header installation. It's important to really centrally locate this, that way you don't have any really far line set connections that are coming off of this header. So as we see here, they're all they're close to the same, sizes, except for this one right here in the middle. But pretty much the basic concept is centrally locate that header. That way you have reduced piping to do whenever you're out in the field. So moving on here, these additional pieces, or dog legs as we like to call them, will allow you connection of a 5/8 pipe. So pretty much it's an extension of the service valves from the actual compressor service valves to the outside of the unit. So these will take you to the right-hand side, and it'll penetrate through the access hole and let you connect your line sets there. That way you're not having to use a ratchet bender or fittings to be able to get up there to the flared connections. These dog legs actually let you connect the dog legs at the service valves and come outside of the cabinet. That way you're not having to do any of the ratchet bending or fittings. And each outdoor unit comes with these, so they're from the factory. They're not anything additional. So moving on here, the R32 MultiPRO also has shipping brackets as the 410A. So be sure to open up the sound jacket that's on the compressor and actually take those out. That way you don't have any unnecessary vibration or wear and tear on that compressor via the mounting brackets. So moving on, the nitrogen pressure test. This is another one of those things that pretty much stays the same. So once the piping is complete, pressurize the system through both service valves. Start at 150 and hold for 3 minutes. Increase to 325 and hold for 5 minutes. Increase to 500 and hold for 1 hour. And here's a chart on how to do that. Duration, examples. The evacuation. So, you always use a micron gauge, because how are you going to know how many microns you have pulled down with your vacuum if you don't have a micron gauge? You can connect your liquid and gas, perform a triple evacuation. It's always recommended. It always ensures that the system is dry, and it often is quicker once you do verify that you do the triple evacuation. So the first step is pull down to 4,000 microns, hold for 15 minutes, break with some dry nitrogen, hold for 20 minutes, pull down to 1,500 microns, hold for 20 minutes, break with 3 psi of dry nitrogen, hold for 20 minutes, then pull down to 500 microns and hold for an hour. If it does not rise above the 1,000 microns, you're good. So this is an example of additional refrigerant, and we've provided a couple different examples here for you, so you're able to decipher how to calculate the additional charge. And this applies to the GMV V36, the 48, and the 60. So as I stated, there's a couple examples here that you can follow and ensure that you have the correct additional refrigerant whenever it comes to that point in the installation and startup process. The debug process, pretty much it's the same as the 410A. So we know that once we have the system piped together, pull the vacuum, and we're ready to do the actual start. This is after we've released the charge, added any additional refrigerant if needed. We're going to go ahead and verify that the outdoor unit says AO along with the indoor unit and its wired controllers. So everything in the system from the outdoor unit to the indoor units should show an AO. Once that's verified, you're going to go ahead and go through the debug process. And as you reach each step, there's an explanation here as to what they mean. And if you get anything other than this, likely it's going to be an error code. That error code needs to be referenced back to the service manual to see exactly what that is, or on the back of the service panel, which will tell you what that error code means. Usually when you get an error code, it means that there's something that went on with the installation, whether it's communication wire, whether it's maybe power to the indoor units, and so on and so forth. So just depending on what kind of error code you're getting at the outdoor unit will indicate what is actually wrong with the system. And once all those errors are corrected, if you have any, you should be able to easily go through this debug process and have the system fully operational within 40 to 45 minutes. One of the other things that we like to mention is the cold weather startup, especially now that we're in October. This is very crucial for compressor and compressor life. In cold weather, the compressor must warm up before system startup. Connect power to the outdoor unit and follow the chart below. So before, we recommended an 8-hour warm-up period, but that's no longer necessary. We have actually, along with the factory, have come up with the actual values and actual duration of the compressor warm-up, depending on the temperature that it is in the area or the outside environment. So we know that anything above 50 degrees is going to be a 1-hour warm-up period. Anything between 32 and 50 is going to be a 2-hour. Anything between 14 and 32 is going to be a 4-hour. And anything below 14 is going to recommend that 8-hour warm-up period. This is to ensure, as I stated earlier, that compressor, lasts as long as possible. Failure to follow this will result into catastrophic compressor failures. Maybe not initially, but prematurely. You'll notice during debug, this, along with a couple of other steps, will actually stop, and it will not continue unless you actually manually confirm whether the value that the control board is receiving is correct or not. So if we stop at debug 08 and UO, this means the compressor warm-up period. And if you have already followed these steps, you can go ahead and hit SW3, and it'll continue on its course to doing the debug. So continuing here, the ducted unit static pressure. Similar to the 410A, there are 9 static pressure settings in the wired controller. The units are default for 5, so make sure that you're taking your static pressure across the air handler and adjusting as needed. We recommend that the total static pressure be within 0.4 to 0.5 static inches of water column. Anything below or above that will need to be adjusted. So as long as you're within that 0.4 to 0.5, you're good. And here's an illustration on how to actually take the static pressure. As I said, you'll take it across the air handler, so in the return plenum, the supply side, and depending on what value you get is how you'll follow the static pressure settings. So as I stated earlier, here's an explanation on what a main unit explanation actually means. There's one wired controller that's going to be designated as the main indoor unit. We need to not confuse this with main indoor wired controller. So the main difference is each system that has a wired controller will be designated as a main wired controller, but there's only one main indoor unit. That main indoor unit is what controls the mode from heating to cooling. So you know if you go to a controller and you try to change mode from heating to cooling and it doesn't give you the option, we know that that's a subordinate controller. Moving along, the A2L refrigerant leak alarm reset. Below is the illustration on how to reset the A2L alarm if it ever trips. So what you're going to do is you're going to power on the indoor unit, select fan mode, set the temperature to 68 degrees Fahrenheit, and within 5 seconds of doing that, press the light button 5 times in a row. And we know that this will actually reset the refrigerant leak sensor. Below is how to reset it through the XE7C23H wired controller. It's a similar process. You just press menu and OK button, which is the same button, it's just the designation on the controller as you see below. So what you can do is press left or right keys to get to highlight set, then press menu / OK. Press up or down buttons to scroll to parameter settings. Highlight parameter settings, press and hold menu OK button for at least 5 seconds, and the project parameters will appear on the screen. Highlight project parameters and press menu OK. Use up and down arrows to scroll to page 5. Use up and down to highlight lock status of refrigerant leak sensor. Use the right / left arrows to change the number to 1 to 0. This will reset the sensor and is no longer detecting a refrigerant leakage. So that's how to reset. So pretty much you have to go through the parameter settings and actually physically change the locked status of the refrigerant leakage. So what that means is you have to go in and clear 1 to 0 to be able to do the reset of the refrigerant leak sensor. Okay, everyone. Well, that was a quick start guide for MultiPRO R32. And I really hope this file helps you, as it has a ton of information to help through installation, through commissioning, and through anything that pertains to the R32 MultiPRO product. Remember, at GREE, we're by your side.
All right, welcome back, everyone. Hope you enjoyed Jesus going through that quick start guide. If you haven't already become aware of the quick start guides and why we do them, right? Because nobody wants to read through a 200-page manual. Sometimes things are missed in the service manual and stuff like that. We don't always have in there what you guys really need to know. Part of what's in that quick reference guide that Jesus talked about was about the refrigerant alarm resets. That is not in the service manual. That's part of the reason why we made sure we got to put it in the quick start guide. Anything that we come across that we feel is important that you guys need to know when you install one of these systems, we try to put it in that quick start guide so you guys know exactly where your quickest reference is to get answers to that equipment. Okay, because that's a short page document that we can do. We can switch it up pretty quick, put in information, and get it reposted on our website. So whenever you have something come up and you can't find it in the service manual or anything like that, always look at that quick start guide. The refrigerant charge examples in there, how you calculate that charge. We wanted you to have good quality examples of how to use those formulas and calculate that charge. The basic pipe layout and stuff like that. Most of your MultiPRO systems, you don't have to use selection software. You don't have to use our system builder app to actually be able to lay out your piping. You can do that just off of following those basic rules that we have in that quick start guide. We just recently got done updating, and I'm not sure if we put it on the website or not. Jesus, you can answer that for me. We just redid the quick reference guide for MultiPRO R32 as well. Did we get that on the website yet, Jesus?
That is not on the website, not yet. I
Okay.
believe it's a printable version, but it's not on the website yet. But it is ready. It's just not up there yet.
Yeah, so within the next few days, we should have that up on the website as well. Anyway, so like I said, guys, updating the service manual, that takes more time. The quick start guide, we can update things a lot faster there, and that's why we do the quick start guides. And it also, it's an easy document to read. So if you go to install one, you've got that quick start guide that's going to give you the basics that you need to know to be able to get that system installed and up and running without any problems. So
I'm sorry, Greg, can I butt in real quick?
Sure.
Sorry, you had said quick reference guide. Okay, so the quick reference guide, that's different from the quick start guide. The quick start guide is up and ready on the website. The quick reference guide isn't. And the quick reference guide, is the pretty much all the selections for the MultiPRO R32. So that's what's not up on the website. But the quick start guide is the one that we just went over in the video.
Yeah, but thanks for explaining that, Jesus, a little bit further. But realistically, so there's two different documents, right? You got the quick start guide and the quick reference guide. The quick reference guide we just got done with doing, and that is being, I don't think that's on the website yet. We're going to get it up there. But with the quick reference guide, if you guys aren't familiar with it, that gives you a listing of all the outdoor units that are available, all the indoor units that are available, and then also has the basic piping rules and accessories and all that stuff listed on just a two-page document.
Right.
So we do have that ready. It's not on the website. Within the next day or two, we'll have it up there for you. Okay. So, and like I said, again, that quick reference guide and along with the quick start guide are our quickest ways of being able to get information to you guys. Because, redoing submittals, having submittals ready, installation instructions, service manuals, any updates to that kind of stuff takes a lot longer than these two quick guides, the quick reference guide and the quick start guide. That's the reason why part of the reason why we have those. Okay. So anyway, I hope you enjoyed what he went through there. And matter of fact, that if you'd already seen that quick start guide within the last day, like a couple days ago, if you already seen it and you downloaded it, go back out and downloaded it again, because Jesus just got done freshening it up a little bit, and it was literally just last night was swapped out. So he refreshed it, and it's back up on the website now with a little bit cleaner look to it. So anyway,
yeah, Greg, I just wanted to mention, the R32 quick start guide. A lot of people don't notice. A lot of the stuff, it's similar to the 410A model quick start guide. So I just wanted to mention that. And also to add, I don't know how many times we've had people or other techs on the line and where we've referenced that document and they're like, oh man, this literally takes me from A to Z, to pretty much start the system up. So that document it's really crucial for people, that are freshly new to the MultiPRO or even, seasoned into the MultiPRO. It literally helps them pretty much cross their T's and dot their I's and help them throughout the commissioning and starting up of that unit.
And we get quite a few technical service calls where, they're not wiring the communication wiring properly. They're using grounded shielding. They're not doing the shielding properly. We got some clear cut examples in there how that wiring should be done. So it just, like I said, it's a quick start guide is a quick reference guide for you guys installing the equipment to know exactly how it's supposed to be wired, know exactly how to debug the unit and stuff like that. So it's just, instead of having to read through a whole installation manual or service manual, it pretty much gives you those key things you need to know at installation. So anyway, before we jump into Q&A, I do want to share something else with you guys. We're going to go ahead and get that up on the screen now. So I don't know if you guys have everybody that's on, if you tune into our Talking Comfort Lives, but if you have not, that's why we're promoting here as well. What we just did in a Talking Comfort Live, we've got this whole contest going on. So submit your art, win a service tool. So, and we got examples there of drawings that have been submitted so far. So there's your competition. I want to encourage people to get involved. I want you guys to send your entries to greecomfortac@gmail.com. Winner will be announced on December 3rd on the Talking Comfort Live show. If you've never been on a Talking Comfort Live show, you can register for that in the same place that you registered for these. If you go to the website and you go under the contractor, go under training, scroll down, you'll see all of our broadcasts that are coming up. We'll kind of show you that real quick. So go under contractor, and then you just you'll see training there. You click on that, and that's going to bring up this screen, and you just scroll all the way down, and it gives you the calendar events for all of them: Talking Comfort Lives, Tech90s, and live broadcast. So just while we're on here too, and we've already got it pulled up, I'll go ahead and share the 29th and the 30th of October. Those are going to be live broadcast. I've got brand new R32 MultiPRO system installed down there. Didn't know it was going to be happening, so we'll do it as well. I've got 2 air handlers set up down there. So when we do that startup, part of that's also going to be I'm bringing down a heat kit. We're going to install one of them heat kits in one of those air handlers and show you that as well. So in between those 2 days, we're going to do a lot. We're going to do a startup of the system, heat kit, installation, the using the service tool on it. I want to show you guys that that service tool is the same for both R32, R410A. You're going to be able to use the same service tool. And we're going to go through a lot of the diagnostics on that again as well, because I think it's extremely important to understand that service tool, because, you know, I don't remember if I said it in the video we're getting ready to play up. You'll see, but, you know, guys, that service tool is worth every penny. Because you get out there, you don't even got to hook gauges up to it. You plug up the service tool, and you got everything you want to know about that machine in the palm of your hands.
Yes,
Questions?
sir. Yeah, of course. We got.
What do we got?
So we have a couple of different. Let's start here. So the first question that we had was: is the R32 Quick Start Guide the same as the 410A? You know, as I stated earlier, and it's well. Go ahead, Greg.
Yeah, yes and no. Some of it is, but the piping rules have definitely changed. So you got to look at the pipe sizes. For example, before with the 5-ton, you use a 3/4 line set. As you will see in the rules now, the 5-ton is a 5/8 line set. So, and then the piping sizes to the all the heads are not exactly the same as they used to be. So piping rules have changed a little bit, but a lot of it still is the same. In other words, so before if you went over 50 feet with 410A, then your line sizes got to go up one size. Like, so if you say you were using a 9K indoor head and you had a 1/4 3/8 line set, but you go over 50 feet of line set, then that would go to 3/8 and half. So both sizes would go up one size, right? When you go over 50 feet. That rule is the same with 410A or R32. So some of it's similar, but that's why we've thought it was important to have a separate document for the R32 MultiPRO.
Well, Greg,
What else you got, Jesus?
Well, I just wanted to kind of go back behind you and say, you know, the one of the best features I personally think is the power kit, not power kit, the, you know, rid of the single point power kit that was on the 410A models. Now you don't even need that. Now you can power all the indoor units via the outdoor unit via terminal block. That is
provided you go with the higher MOP and the
exactly.
higher
Yep.
Correct.
And I mean, obviously there's restrictions. You know, if you have an air handler and it has an electric key kit, well, you know, that's not going to be, you know, possible. But, you know, with the ultra heating of the outdoor unit, I mean, chances are you may not even need a heat kit, you know, in those cold temperatures. So
correct.
That's personally, I think that's one of the best, you know, features that we've added to the outdoor unit. So that's, you know, you pretty much, you know, how many times have we gotten a call from contractors? Oh, you can't power this thing up from the outdoor unit. It's like, no, not the 410A models. But, you know, back then we would say, well, the R32, you can, but it's not here yet. But now it is. So now it's, you know, when, like I said, personally, my favorite feature of the outdoor unit on the R32.
But also, we pushed hard to have the dual rating like that, though, because what if you're doing replacement work and you've already got power supply out there? You know, if you had to have a 5-ton, or say you're putting in a 3-ton unit and had to have plus 60 amp power to it, nobody's going to want to do that. So you have the ability to be able to do it as powering just the outdoor, or you have the ability to power the outdoor and the indoors with a higher amperage circuit. So we pushed for it to be versatile for you guys out in the field for either new construction or replacement work, whichever way you're trying to do things, right? So
Right.
anyway, any other questions?
Yeah, so we have another question coming in. It says, do all previous controllers like the XC7C23H, the central controller, and the XK46 work on the R32 MultiPRO?
Yeah, so all of those controllers are backwards compatible, but keep in mind the capability of some of the controllers are not always the same from one controller to the next. The example is the XC7C23H is the current controller that is coming with the R32 equipment. And if you're using an air handler with electric heat, you have to have that controller in order to be able to recognize and get electric heat to work properly. If you have an XK46, it won't work properly. So keep that in mind. The XC7C is the only controller that is set up to be able to control that electric heat properly. So, and then also on the 24 volt adapters, we have a ME3233H and an ME3223H. The 23H is the latest of the service tool. And if you're using an air handler with electric heat and you want to control electric heat, you have to use the ME32-23H. So, and that's listed in the new quick reference guide that's coming up. We have both of those 24 volt adapters listed there and what thermostats you should use with it. So the original 24 volt adapter, the ME3233H, you would use a standard heat, one cool thermostat, not even a heat pump thermostat. You don't even use OB terminal or anything. But if you're using an air handler with electric heat, now you're going to use the ME32-23H. Why they went down in a number, I don't know. But the 23H, then you're going to use a 2 heat, 1 cool heat pump thermostat, and you will utilize an OB terminal, and you will energize off of B during heating mode to energize the reversing valve, and then you will also have full control of auxiliary heat and or emergency heat with that 24 volt adapter. So again, that's all listed in the quick reference guide that we'll have up on the website hopefully by tomorrow. So
yeah, Greg, I think it's important to say or to reiterate this about the XC7C23H. That is the controller that comes with the ducted units for the R32 equipment. So
correct.
That the distributors know, like, hey, I don't need an additional controller because this XC7C23H already comes with the ducted ones. Now it's
so
optional.
all of the units that require a controller, which would be like a ducted unit or an air handler, because I mean, the easiest way to remember this is if it's a wall mount, obviously a remote control can control a wall mount. A remote control can control a cassette because you can see the display in the room. A ducted unit, an air handler, is not going to be installed in the same room. You can't see it, so that how can a remote actually control it? It can't. So it's going to come with a wire controller. So all of the ducted units in R32 are now coming with the XC7C-23H. That is the standard ship controller with all of the ducted R32 units. 410A wasn't the same.
Right.
So what else you got?
All right, moving on here. So we have, is the R32 software available? And if not, when? I believe that they're talking about the selection software, so the VRF selector.
So 2 things still got to happen. The selection software is not up yet because it doesn't have all the equipment. We'll have some conversations internally here, see if we can't go ahead and get that put up, even though it doesn't have all the equipment offerings in it. But your layout can be basically the same. In other words, let's say, and I don't take me for granted here. I don't remember which units are missing, but let's say the air handlers aren't on there. Okay, you can still do a job layout. You would just use a cassette of the same BTU. It'll still lay out your piping and everything, give you your charge amounts and stuff like that. But the problem is right now, the software doesn't have all of the indoor unit offerings in it. That's why it hasn't been put up yet. So we'll work on that. And then also our system builder app still is not ready for R32 yet either. that's part of the reason why I wanted the quick start guide done so quickly, is because in there you can use the basic layout, for your job layout, and you also have the manual calculations to figure out your charge. I know it's a little bit, trust me when I tell you, I'd much rather use selection software or assisted builder app because it's faster, but you still have the ability to do it. It's just going to take you a few extra minutes to do the manual calculation to the charge amounts. So, and just remember your rules. You're going to use the size line set that goes to the indoor unit, provided we're not exceeding 50 feet. If we're exceeding 50 feet, take both pipe sizes up one size. So if you're at 1/4 3/8 and you're going to go over 50 feet, then you need to go to 3/8 half. Okay. So I always discourage against that. And not really discourage, but always make sure everybody knows when you do that. Let's say you got a 9K indoor unit and your piping is going to be over 50 feet. So you got to go up one pipe size. Remember, you got to reduce back down to connect to that head, because all of them are flare connections. So if you're running 3/8, 5/8, but your line set size at the unit is 1/4 3/8, you're going to run the 3/8 half inch. I said 5/8, but say you got 3/8 half inch. When you get to that head, now you've got to reduce back down to 1/4 and 3/8 to be able to connect up to the head. That's why I always try to encourage, if you can lay out a job and stay under that 50-foot rule to all of your indoor units, that is the best way to do it, because then your pipe sizes to your indoor units is going to match the connection size at the indoor unit, and it just makes the job simpler. So anyway, so sometimes you're better off to use multiple Ys than you would one 4-port or 8-port header. That's where I'm going with that as well. So, all right, Jesus, some more questions?
Yeah, we have a question here. We have quite a few. Let's see, I'm trying to pick what's the way to answer that one. So, if you're powering the indoor units on a MultiPRO unit from the outdoor unit, are you still wanting a disconnect at every IDU indoor head?
I would. I would still you don't have to be an AC disconnect. It could be a 2-pole switch, because then that gives you the ability. Let's say you got 4 indoor units and you need to service one of those 4, and we still maintain over our 50% connected capacity. I can turn the power off to that one head and work on that one head and allow the rest of the system to function still. I don't have to kill the power to all of the indoor units.
Well, I think that's crucial to mention on that, because I know I've worked with equipment in the past where you shut down one system, interior system, and the whole system is just out. It's not functioning. So that's another key feature to the MultiPRO product.
The MultiPRO product, as long as we maintain 50% connected capacity, the outdoor unit can still function.
Exactly. So, I mean, I guess just to add a little bit more to that, you'd want to add a 2-pole switch for like serviceability, like you were saying, right, Greg?
Right. Like I said, when we say indoor disconnect, a lot of people think immediately you got to buy a 60 amp AC disconnect for all of your indoor units. Most of your wall mounts, cassettes. Now, an air handler with electric heat, yes, you're going to have to use a pull-out disconnect or a breaker, right? But an air handler without electric heat, you can just use a 2-pole switch. It's only got a 15 amp rating to it. So a 2-pole, just like a light switch, as long as it's 2-pole. Remember, you've got to kill both L1 and L2. You can't use a single pole switch, because then you're still hot on the other leg, and you're going to find out about that when you stick your hand in there.
Right.
And I don't wish that on anybody.
Nope.
So, all right, what other questions we got?
So we had just answered this one. It says, what type of disconnect you suggest at each inside unit? So we just answered that one.
Yep.
So, let's see. This is okay. So this is an installation question. Where is the best location for a high wall head in an L-shaped space? So
that's a good question.
I don't understand. What do you mean L-shaped space? Is that just like a wall in the ceiling?
Well, I mean, I'm trying to picture a room that's shaped like an L, right? You got to allow for throw
Oh, I see. Okay.
off the wall mount. So I would think you'd be you'd be wanting to deliver the air mostly across the long length of the L, right? Not the short length of the L.
Right.
Which remember, you got turning vanes, so you can turn the airflow a little bit to get a little bit of air to go to the short side of the L, but the majority of your air flow down the long side of the L.
Yeah, that's correct. Okay, yeah. So the wall mounted unit, you could, like you're saying, set that vane to pretty much point all the way down, right? Or
No, left to right. What I'm saying is, so if you put it on the wall where it shoots down, your throw off of it is shooting down the long part of the L.
oh, I see, I see.
Now you've got this cavity on the short side of the L that's not really getting much airflow. So you turn your vanes to where you get a little bit of airflow going toward that short side of the L, but still the majority of your throw is going down the long side of the L, is the way I would do it.
Right. Yeah, I agree. I
Now,
agree.
just like as if you're doing a wall mount in a garage, I always encourage people, like say you got a 2-car garage, you want to throw across the garage, not at the garage doors.
That's correct. Yeah, that's exactly how I have it set up in my house. It's the same way. And I debated about that for a long time with you. I was saying, well, if we do it this way, it's gonna hit this wall sooner, and you just don't want that. So
Yeah.
okay.
Yeah, you don't want bounce back, because these things, depending on the size of the wall mount, if you're doing a 2-ton wall mount, again, that thing's got a pretty good throw to it.
Yeah.
And that's what I have in my garage is a 2-ton wall mount. And I can feel the air blowing off of that wall mount. It's not loud, but I can feel that all the way in that third bay. It's got a pretty good throw to it on a 3-car garage.
Not to mention with the wall mounts. Go ahead, Greg.
I'm just saying you got to be mindful of that throw coming off of that unit, and that it's not going to be, you're not hanging a wall mount where it's going to go and hit a wall and bounce right back,
Right.
give you recirculation. That's going to cause problems.
Yep, I agree.
All right, what else we got?
So moving on here, you see this installation question. Yeah, we got another question here. Powering the indoor MultiPRO heads from the ODU, what gauge wire do you recommend?
So if you're going from the outdoor unit to your indoor unit, you would size it to the load size of your indoor units, which the majority of them are going to be a 15 amp circuit, right? So 14 gauge wire should handle that with no problem.
Right. It's almost like when you're looking at a room, how many sockets you're going to have, right? That one 15 amp wire is going to disperse into all those circuits.
Just remember, any wire coming off of it that's exposed to the outdoors got to be in protective conduit or whatever rated for outside, right?
So I guess you would almost say it's almost identical to the daisy chain, right?
Well, yeah, you can actually power more than one head off of the outdoor unit,
right?
Because most of the wall mounts and stuff, you got to look at the MCO and the MOP on each one, but most of them probably only got like a 1 amp rating, so you can easily power 4 or 5 units off of 115 amp run,
right?
115 amp circuit, right? So
okay, let's see. We have another question here, but it looks like more of a sales type question. So it looks like he's left his number here. It's Mark. He's asking a couple of different questions regarding our products. So I think we can reach out to him directly if he's left his information there. So we'll just save that one for after.
Okay.
Online.
What else?
Well, yeah, that's it. That's it for the questions so far. So guys, just keep on engaging with us and keep on asking us.
So with that, I think we should go ahead and roll the next video clip. Like I said, this is done from a previous training. This machine that I'm working with, this is a previous training I did down in Atlanta. The machine I'm working with is a 410A unit. But as far as the diagnostic goes and everything I'm talking about in the whole video, is going to be the same with R32. So let's go ahead and run that clip, and then we'll come back and do some more live Q&A and talk to you guys.
On this screen, you will see that I've got a mini split piping diagram. And the reason why I brought this up is from yesterday, is to mainly point out in a mini split system, your EEV or capillary, so these you can use EEV and a capillary, or they can use just an EEV, or they can use just a capillary. But as you see here, your metering device is in the outdoor unit. That's the main point here. So we go into a multi-zone. You've got a set of refrigerant lines for each indoor unit. So one indoor unit is going to have a gas pipe, and it's also going to have a liquid pipe for each indoor coil. So when we get into MultiPRO, we're not doing that. It's a little bit different in that we are using one set of pipes out to the condenser, and to me, it's a cleaner look to a multi-zone type of system where you have one gas pipe, one liquid pipe that comes from the outdoor machine all the way to your indoor units. So as you can see right here, these would be your service valves on the outdoor unit, your small valve and big valve. They call them the small valve and big valve because they're not really, you know, the way we've always done unitary product or traditional heat pumps, stuff like that, that we've always called them liquid and suction line, right?
Right, yep.
So on these, though, it depends. You know, if you're in heating mode, the big line is going to be your discharge. Your small line is still going to be your liquid. And then in cooling mode, your small line is going to still be your liquid. Now, then the large pipe becomes the gas pipe. So in a lot of piping diagrams that you will see in the MultiPRO mini split world of heat pump systems, they call them small pipe, big pipe, or they'll call them liquid and gas.
Right.
Because it could actually be hot gas or it could be low pressure gas. And then if you actually venture off and go into like commercial three-phase equipment, a lot of those are three pipe, where you've got a low pressure gas, a high pressure gas, and a liquid.
Those are heat recovery, right?
Yeah, in a heat recovery system. So, you know, that's why that terminology is used that way, so it's less confusing when you're talking equipment in that world of equipment. So, and the only reason why I'm spending time talking about it is because it's not the same terminology that a lot of guys are used to that are just now getting into a system like a MultiPRO system, or even really doing a deep dive into mini split systems. So I think it's important to talk about it. So what I want to talk about here is, and I'm going to reiterate it with some equipment we have set up here, but on the MultiPRO system, it works a little bit different than the mini split system. In other words, as you can see right here, that is a shared liquid line. The metering device is on the indoor unit on both of these indoor systems, okay? Now, these indoor systems could be a cassette, it could be a ducted unit, it could be an air handler, it could be a console. We have an array of different indoor unit options. And then you have a common headered gas line that comes all the way back to the machine as well. Now, I know there's some people on here going, man, that'd be nice to have those piping diagrams. Well, you do have access to these piping diagrams. All the piping diagrams I'm going to talk about today come out of the service manual. When I ever get time, I would like to highlight this diagram and make it a little bit more user-friendly to easier to read. This is an example of a machine in cooling mode. And I brought this one up specifically for a reason. Because if you look out here, this is your outdoor coil. This being the outdoor coil, this unit running in cooling mode, and I actually took this call on a MultiPRO Ultra B revision. This is a standard, but the concept's the same. This outdoor heating EEV, so if we were in heating mode, that is my EEV for heating mode, and is going to meter my refrigerant into the outdoor coil in heating mode, because now this became my evaporator. These two coils become condensers. Okay, so at that point, we are flashing refrigerant this way. But if we were in cooling mode, that EEV has got to be all the way open. So the EEVs in a MultiPRO system are from 0 to 480 steps. It's a little motor in there that drives the needle seat open and closed. When it's all the way open, we get free flow through it. If for some reason in cooling mode that EEV wasn't open, then we would be going into a pump down, because it'd be no different than if you took your service valve, your small service valve, and closed that thing up. Now we're going into a pump down, pumping all the refrigerant in the outdoor unit, and it stops between this liquid pipe right here, or liquid valve right here, backs up all the way into this coil, up to the compressor. So all of our refrigerant is sucked through this gas line back into the compressor and stored in the condenser coil. So the reason why, part of the reason why I'm bringing this up is because a lot of troubleshooting that guys call us about can be easily answered just by doing some simple inspection. This was actually, the call I'm talking about was the fault of GREE. It was not the installer's issue at all. The solenoid valve on this EEV was dangling in the unit. It wasn't even on the armature of the EEV, so there's no way the motor could actually open the EEV. So this was 100% closed and pumping me down. And once he took the side panel off of there, and I told him to look for these EEVs, he found that coil just hanging there. We put the EEV coil on that valve body and had that machine up and running with no issues. So just
so doing a simple inspection just would have solved that.
Right.
Yeah.
So this piping diagram, I want to talk about this some more as well. This is the Ultra, the new GMV6 MultiPRO Ultra. As you can see, and that's why I'm pointing this out so you guys can follow along. Here's your outdoor coil. Here's that EEV that I was talking about again. Same thing. If that EEV is not all the way open, now you guys got an unloading valve here, but still, if this EEV is not open at full 480 steps during a cooling cycle, we're going to go into pump down because we don't have any liquid refrigerant feeding out. It'd be no different if I close this service valve. So if that EEV is not working, or if the coil is not on the valve body, just like the one I ran into, you're going to have that same exact scenario. This EEV here is strictly to help subcool the refrigerant. So this is a little confusing to look at when you look at the piping diagram. That liquid line is straight through that subcooler. This subcooler, it flashes refrigerant into the subcooler and will make that liquid colder. So when they say that's the subcooler, that's exactly what it is. It's the subcooler, because in some instances, depending on the load of the machine, it may need to subcool that refrigerant some more. So I hope I make that a little bit clearer. And on the service tool,
is that just to take the load off of the compressor or the unit itself, or
it's to get your liquid temperature down so we get a better flash point at our indoor EEV.
Okay.
Okay. So again, that's going to be dependent upon other load conditions within the machine that our outdoor board is constantly looking at. All the thermistors and stuff like that, just like we talked about in the mini split yesterday. It's constantly digesting all of the data that it's getting to know what the machine needs to do. In other words, as far as what the speed of the compressor, the speed of the outdoor fans, the speed of the indoor fans, what step the EEVs are at, whether you're in heating mode or cooling mode. You know, they don't have to be wide open, right? So we'll go back to this diagram, because this is going to be more, we need to understand this better once I got that service tool in my hand and I start talking about that later on in the broadcast here. It's a building system here. Let's say I got a situation with a system where intermittently getting compressor error codes. But you as the technician, every time you go out there, and let's say you've got this piping diagram shows 2 indoor units. Let's say we got 4. And you never get it to duplicate the issue while you're there. Okay. But every time you go there and you reset the error code, whatever the compressor error code may be or whatever the error code was, you reset that error code and you start up the system and you bring on all 4 indoor units. and you monitor it for a half hour, an hour, or whatever, and the system's working and it's not going down on fault. And you're thinking to yourself, well, maybe it's just a, maybe it was just a fluke. And it went in, maybe it was some scenario that caused that thing to weird out and shut down. But we all know that that's probably less likely. So what I'm getting at here is that's when the service tool or the GREE controllers, we're going to talk about that more. I'm just trying to prep you guys for where we're going with all this. Each one of these coils has an inlet and an outlet temperature thermistor on that coil. When you have the service tool hooked up, not only can you see the temperature of the outlet of that coil and the inlet of that coil right after your metering device. So if you're in cooling mode, that ought to be flashing off pretty good, and we ought to have a fairly cold input to that coil, right?
Yep.
Then as it travels through, the refrigerant travels through the coil and absorbs heat into the coil, our leaving thermistor should be significantly warmer than our inlet, right?
Oh, yeah.
That's the data that I keep telling you guys the service tool will answer for you. So if you've got 4 heads, look at the data on each coil. Look at the EEV step. Let's say that thing's open at 150 steps. And that inlet temperature sensor is basically room temperature. What does that tell you? I'm not getting any refrigerant into that coil. Could I have a bad EEV? Yeah, it's likely.
Or restricted strainer.
But you could also have a restriction in the refrigerant line. You could have a restriction in your piping. You could have had where when you bent the pipe, you didn't know it, you kinked it. I don't know. I'm just giving you all scenarios. I'm not throwing the blame to anybody. But if that EEV is wide open and I'm not getting that temperature differential and I'm not getting that flash gas right there entering that evaporator, then I know that indoor unit's a problem. And if I have 4 indoor units, the other 3 are working fine, I'm not going to get that compressor error code. But if I go in there and I shut this one down, shut that one down, shut the other one down, and leave that one on, now there's a good possibility I'm going to get a compressor error code because the refrigerant's trying to pump up against a block that it can't get through. I'm not getting my cool refrigerant gas back to the compressor. The machine's going, what is going on here?
Either low pressure or high pressure fault.
Possibly, or even just the amp draw on the compressor went too high because it's beating up against the head pressure.
Right.
You do have high pressure switches in it, as you can well see in this diagram, but that doesn't mean that machine's going to fault on high pressure before it faults on something else. It also depends on the type of restriction, and I've dealt with this even with standard equipment. When you have a block in refrigerant, let's say your restriction, maybe we close this service valve back and we start backing that liquid up in here. This is what I've seen even in traditional equipment. If I got a restriction, let's say I got 1 indoor coil, 1 outdoor coil, I've got a restriction. When that unit fires up, that head pressure will go, if you watch your gauge, will go way up. And then all of a sudden it starts falling back down. The reason being is because you've pushed that liquid up against that block, it can't go, it can't go, it can't go. So now it just starts stacking that liquid all the way back into our condenser coil, and the refrigerant's just kind of sitting there stagnant with nowhere to go. And since I'm not able to suck any back to actually pump it, I can't build that pressure anymore. The pressure drops.
Yep.
So right at startup, you get high head pressure. Maybe not high enough to trip a high pressure switch, but then we start backing all that liquid up into our condenser. Okay? So just because you've got a restriction, and this is where I've seen a lot of guys go wrong with that in the years that I've been troubleshooting and dealing with HVAC equipment and refrigerant flow issues, everybody always wants to think that if I've got a restriction, I'm going to have high pressure. That's not always true. You may have high pressure to start with, but once that liquid backs up within the system, it can't move anymore, head pressure drops. Again, I just wanted to share these diagrams with you guys a little bit. This doesn't show the indoor units. This is the piping for the GMV6 Ultra in cooling mode. This is the one for heating mode. We did revamp these diagrams a little bit to put an actual reversing valve in there. It makes it a little clearer to see the flow through the reversing valve. And if I go back in my piping diagram, this is the way GREE does them. They just have this little circle up here, which to me is a little more confusing than it is when I actually change up the diagram. So, I mean, this is their diagram. All I did was, and had this put in the service manual, all we did was take out their little circle and made an actual reversing valve. We didn't change the piping at all. And the same with heating mode, just kind of showing your whole flow through and highlighting it, making it a little easier to read. When time allows, hopefully we'll have time and we can highlight this diagram a little bit better and take this out and actually do a reversing valve picture in there. So let's now talk about the service tool. This is the box that the MultiPRO service tool comes in. It does come with the instructions on how to use the service tool, just so you know. The service tool, this is it. I've actually got it popped apart. I've got this one hooked up because this is the one we're going to be using in today's training class. But what I want to point out here is I'm using a portable power source with a USB. You can use a portable battery. It's plugged into the wall. This is the tool we're going to be talking about. It's that same tool. I just wanted to point out when we switch up, I'm not switching tools on you. But, so here's the deal. In the box, you're going to get this cable. This cable has these little gray keepers on here. So when you get this tool, the first thing I'm going to tell you to do is get your little pocket screwdriver on these little gray tabs on the side. It's not hard to do. Pop them off. Don't put them in the box. Put them in the trash can. You don't want that on there.
Because that way we can't plug it in, right?
Well, you can. It's getting it unplugged.
Right.
Is the trick. So then when you go to plug it into the service tool that's all together, when you plug this in, it'll clip in there. But what I've found, if you have that plugged in, then you can unplug it and plug it back up. If you do it and leave that keeper in there, it keeps you from squeezing that tab to be able to release it. So you really fight getting it to unplug. That's my whole point there. So make sure you're getting rid of them gray keepers. Most of the units on MultiPRO, whether it be a cassette, a wall mount, a ducted unit, they have the 4-pin Molex plug on the circuit board in the machine that you can plug up to make the service tool work.
That's on the indoor head, right?
On the indoor unit. Sometimes there's more than one 4-pin plug. Don't worry about it. You don't need to know the specific number of which one you plug into. The one thing I can tell you is if you plug into the wrong port, it won't hurt the tool, it won't hurt the machine.
It's just not going to give you the readings.
Just look at the 4-pin plugs, plug it into one. If it works, so you got the right one. If it don't, you got the wrong one. Trust me when I tell you, it won't hurt the tool. But some of the machines, like the wall mounts especially, that plug-in is all the way in the back of that circuit board. So getting to it is not the most friendly way to be able to hook up your service tool.
Right.
The outdoor machines, the standard MultiPRO and the new Ultra do have the 4-pin Molex plug on the board for you to be able to plug up the service tool. The MultiPRO Ultra B revision did not. On the outdoor unit, there is no port on that board for you to hook the tool up to. So you can do this a number of different ways. I found these on Amazon. They are 4mm 4-pin connector. I think I paid $8 for 20 of them. And it's just a female receptacle plug. It will plug right up to here. The colors don't match, but don't care about that. Red and black on GREE's plug, red and black of this plug is D1 and D2. Brown and orange is power supply.
So the two center ones is what we want to use.
Two center ones. So if I put this little adapter on here, again, it's not color matched.
The two center wires is all you want to use.
I went from red to black to red and white. Then I can take that red and white wire and hook it to D1 and D2 anywhere in the system as long as I have the portable power supply hooked up to the service tool, the portable power supply will power the tool. This will give you your communication into it. I can hook up anywhere on the system. So, or let's say you don't want to buy those on Amazon because they don't come with the tool. You could do what I initially did, and I just took one of these cables and I cut it off, and then I just set it up to where I only use the red and black wire. But it also made it where I could put the red and black wire and the orange and brown back, hook the plug back together, so I could actually use the whole plug if I wanted to. But then I found these adapters, and that just made life easier, okay? So just an FYI, there's more than one way to skin a cat, right? So, but if you are going to use the portable power supply, I do highly recommend that we are, securing that port, because just a few times plugging and unplugging, you're going to break it. All right, so now I want to redirect your attention over here to these couple units that I have, just like the wall mounts, the ducted, the cassettes, all of them. As I said earlier in the piping diagrams, you have an inlet and outlet temperature sensor. So right here is the inlet temperature sensor coming from our refrigerant feed in. And then here is the outlet right on your gas pipe coming out. And then so I'm not have to be bent over anymore. I'm going to come over to this other coil. And I got the whole control panel taken off here just so for show and tell. But here's our inlet pipe temperature sensor. Here's my outlet pipe temperature sensor. So they're a lot easier, a lot closer together on this particular coil. The one thing that I want to point out to you, make sure you realize, is on the service tool, they are marked as inlet and outlet pipe temperature sensors. If you're in heating mode, that's backwards. Because in the tool, it still says inlet and outlet. But remember, you're flow reversed. So now we're flowing hot gas into here. So now your outlet temperature sensor becomes your inlet temperature sensor, and your inlet becomes your outlet because your refrigerant flowing the other way. So you got to keep that in mind when you're in heating mode. Inlet and outlet are reversed. In cooling mode, that is your inlet, that's your outlet. Heating mode, that is your outlet, or your inlet, and that is your outlet. Make sense? Cool. First thing you want to do when you get this tool is because it's going to become set up as metric. You want to change this tool to standard or British system so that you get everything in Fahrenheit and instead of Celsius, and it's going to make things a lot easier. So let me go back one here. Hold on. Project setting is where you're going to go. You're going to go to page 2. You're going to go to controller setting. You're going to go to unit of measure. And as you can see, if I put that on metric, is where it comes. I've already changed my tool to British. And then all I do is hit back, 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 main page. So now everything I'm going to read on this machine data-wise is going to be in Fahrenheit. So it's going to make it real easy. That's one advantage that this tool has over the mini-split tool, because the mini-split tool is all
We have to translate.
Celsius, and you got to translate it all. This tool, you don't have to do that. With this service tool, you can actually force it into startup, or for whatever reason, GREE calls it debug. I hate that terminology because it sounds like you're fixing the unit, and it's really not fixing anything. It's just the startup process. You don't have to use that. We have talked about that in videos before. We got quite a bunch of videos of how you force these machines into commissioning. When you see the AO on the screen, that just means the unit needs to be put through startup. Once it finishes startup in heating mode or cooling mode, you're done. You're ready to turn the machine on. So you can actually do it from the service tool. You can also get system status where it gives you error codes and stuff like that. But what I normally use on this tool more than anything is unit control, and then also observation of the unit to determine what's going wrong with the unit.
So we can check all the sensors, all the EEV steps.
If I go to unit control, I can control the entire system from this tool. So now you got to choose what you're going to drive. So you go to unit control, you go indoor unit. As you can see on this system, there's 2 indoor units. I can do select all, or I can just do 1. So you can see right now I'd only be driving unit number 2. I'm not driving 3.
Right.
But if I do select all again, now you'll see it highlighted both. Now I hit OK. So now I know whatever I do here is sending that command to both units. Then I can put them in heat mode or cool mode or dry mode or fan mode, whatever mode I want to put them in. And I can also set my fan speed. When you look at this, the fan speed, when the arrows are all like that, that is auto fan speed. If I hit it a few times here, that's going to be low. That's going to be like 1 step higher.
Medium, low.
1 step higher. 1 step higher. 1 step higher. It'll go back to auto.
And do we recommend having it on auto all the time?
I do, and I'm going to get into that in just a minute.
Okay.
Plug it up to a USB cord and play with the tool. Go ahead and set it up for British. Go ahead and get it ready to go. Get familiar with, remembering how you drive all the systems on and stuff like that. And you know what? I'm going to power it off. Power it back on. Well, sometimes it'll just, and it's not doing it right now. I probably have to unplug it, but it'll come up CAN bus communication at the very first screen. When you see that, just hit OK, and it'll take you right to the screen. Okay? All right, so now let's actually drive it on, and we can look at some status. So let's go to indoor unit. Oh, not indoor unit status, sorry. Unit control, indoor units, heat mode. I'm going to set it 79 degrees. So now, in order to send the command, I got to hit the check mark. Now it just sent the signal.
Unit instantly came on.
Unit just came on. So it's overridden what the controllers are saying and just told this machine to run. Once they're on, I can go to indoor unit status. I can select which indoor unit I want to see the information on. Let's go to 2. It's telling me on project number 2. It tells me what the BTU of the unit is. It's a 2-ton. Keep in mind, guys, this is a lab unit that gets used and abused. So it's gaining a mind of its own sometimes. I can tell you I do this on my unit at home and it don't do it to me. So let me just do this again. I'm going to send the command one more time. Okay. So we'll wait a minute and let it get started up. Meanwhile, I'm going to talk about something, okay? I constantly get asked the question, are these units variable speed? Are the air handlers variable speed? Are the ducted units variable speed? The answer to that question is yes, they are variable speed when they're in auto mode. The key to that, though, is it's not the variable speed that a lot of guys are used to. What I mean by that is variable speed means, and a lot of guys look at it this, with you in unitary product, in other words, standard systems we've always dealt with, when you put that thing in cooling mode, or you do profile setup on that furnace or that air handler or whatever, on variable speed, you're typically setting it to a specific CFM per ton, right? Mm-hmm. In other words, you're going to go in there, you're going to go to the dip switch settings, you're going to say, I want this thing to deliver 400 CFM per ton. And what it does is it was going to try to ramp and achieve that 400 CFM per ton. And let's say you got a 3-ton. So it's going to try to achieve 1200 CFM regardless of the static pressure on the machine. So if you've got high static, that blower motor is going to ramp up even harder, trying to overcome that static to keep delivering that 1200 CFM. Whether the motor can actually do it or not is a different story, depending on the ductwork and stuff like that. That's not the way variable speed MultiPRO works, or in any inverter-driven unit. The way variable speed works on these is it will adjust the blower speed according to the inlet and outlet temperature sensors and the EEV step and the load that's on the machine. So if you have very little load, you're going to have a lower blower speed. If you have a very high load, then you're going to have a higher blower speed.
Right.
So you don't so I just want people to understand what variable speed really means in in inverter-driven equipment, especially MultiPRO. Okay?
Yep.
All right, so now we're running. All right, so now I can go back. I can go to indoor unit status. I can select both of them, and you can see right now, man, these things are cranked up because I've got such a high demand on it. Indoor number 2 has got the EEV set at 351 steps. Indoor unit number 3 has got it at 366 steps. Now I can hit that number 2 button, go specifically to that unit. It's telling me that's a 2-ton indoor unit. It's project number 2. The state of running is on. The fan mode is stop. Because the way these machines work, the fan's not coming on until the coil's warm. Now it's starting to come on. I think this is the 2-ton, but I ain't gonna swear to it because I got them both coming on anyway. Temperature settings, 82. Indoor ambient is 72. We got a 10-degree demand. Inlet temperature's 91. We're running in heat mode. So now that's actually the outlet. Our inlet is 104. So if we give it a little bit of time, that differential is going to go up. That's what I want to see.
Right.
I should be seeing. This unit number 2 is also the master indoor unit. That also tells us that. The EV steps 367. E-heater's off because this one don't have an E-heater anyway. Left, right. So
That's our louvers.
freeze protection, all of that. Cool. Now let me go back. We can also look at our outdoor unit status. Keep in mind these service tools, this is the same service tool. If I went and hooked up to a 3-phase heat recovery unit, I can view up to 66 indoor units with the same service tool. That's why it's saying compressor number 1 operating frequency 0. We obviously know the compressor is running, so give me just a second, we'll get there. Rated capacity 30,000 BTUs. Outdoor ambient temperature 68 degrees. Fan motors are running at 30 hertz. Compressors at 34 hertz. We're not even begun to really ramp this unit
So
yet.
that's pretty low.
Well, and if you think about it, again, that's part of the whole idea behind this training is hopefully you guys can help start digesting what I'm trying to tell you here. You got to understand what the machine's trying to do, where the refrigerant's flowing, where's my metering devices. If I understand how it's supposed to work, then I can start diving into why it's not working. That's my whole thing here. Well, to me, I got a 10-degree demand, right? My fan motors are only at 13 hertz. My compressor's only at 34 hertz. Why? Well, I'll tell you why. Because the outdoor temperature is 68 degrees.
Right.
If the outdoor temperature was 20 degrees, you would bet that that fan speeds would be higher, the compressor speed would be higher, because I'm having a harder time absorbing heat into the outdoor coil in heat mode.
Got to ramp up.
Because I've got a colder outdoor temperature, okay? That's why I said you got to start thinking like the machine's thinking so you can understand what the thing is doing. It gives me my high pressure and my low pressure, both in pressure and in temperature.
Yeah.
So I'm running 400 or 398 psi of head pressure and 173 pound back pressure. Makes sense to me when it's 68 degree ambient that outdoor coil's in, right? You wouldn't be seeing suction pressure that high if you were in a much colder environment. You probably would still see that head pressure because the thing's trying to build that head pressure so we get that discharge temperature, so we get to release that heat. These things do a great job of giving you a nice warm heat off the coil, and we'll go back and revisit that in just a second. So there's a lot of useful information here. It's also giving me the compressor discharge temperatures, 127 degrees. We talked about that yesterday. All the way up to around 150 degree discharge temperature, or maybe even just a touch higher, I'm not alarmed by that. But if I start seeing that discharge temperature at 175 plus, I'm beginning to wonder why I'm not getting enough refrigerant back to my compressor. If I start seeing it over 200, I know I got a problem. I'm not getting my refrigerant back to that compressor, or I am overheating because of lack of refrigerant. Again, that goes back to what I talked about yesterday with the mini split. I may have enough refrigerant in this machine. If I got 4 indoor units, I may have enough refrigerant to satisfy one, but when I bring in all 4, now I don't have enough refrigerant anymore, and that's why it can't keep up, and it's because with all 4, I'm low on gas. So if I start shutting units down and all of a sudden my temperature rise goes up on that one and my temperature split on my indoor unit, if I go back to indoor unit status, go to number 2, let's see what kind of differential. 124 degree inlet, 90 degree outlet. That's a 25 degree, or no, 35 degree, right?
Yeah, 34.
My math's horrible. 35 degree rise, you know, differential across that. We're heating. We're absolutely heating. That's what I want to see. So now, and I always say, to me, it's a lot easier for refrigerant diagnostics in cooling mode. And these machines will run in cooling mode all the way down to 0 with no problems. So when in doubt, check it out. Run it in cooling mode. That may make the refrigerant diagnostics for you easier doing it in cooling mode.
Good point.
So anyway, that's a good differential. So let's go to unit number 3. And let's take a look at that one. 18 degree differential. Not as high, but still decent. I wouldn't be complaining about that. EV step 339. Remember, this is going to be fairly open anyway. Because when I said, "Whoa, that EV is really calling," and I think about when you step back and actually think about it for a minute. Now wait a minute, I'm in heating mode. I want to open it up. I want to get good flow through there because that's my discharge line, right?
Yep. Oh yeah.
I'm trying to flow. I'm not flowing through my discharge line. I'm flowing in through my discharge line, which would be my outlet of the coil. But I need that free flow of liquid to go out the other side. I really don't want to be metering refrigerant into my liquid line going back to my outdoor unit from my indoor unit. So that EEV should be wide open or fairly wide open in heating mode, right? So maybe go to unit control and we're going to go and shut this down. Oh wait a minute, hold on, before we do that, remember I got to hit the check mark to command it. So while you hold that up there, the other thing I want to talk about is depending on the controller that you have, this is the XK46, the manuals, there is a way to get into it. I'm going to just do it on the XE70 because it's easier and faster, but you can get into it this one too. But this one's super simple, and the XE7C is super simple as well. But I can go right here, and then I can go to View, Enter, and I can go to Project View, go down, come on, up, parameter view. That's what I want to see. Sorry. Gotta play sometimes. Inlet, outlet temperatures. So if you've got a wired controller, you can actually go see this information on the wired controller as well. But if you've got all cassettes and all wall mounts and you don't add the optional wired controller, now you have no diagnostic information because you can't do this with the remote. This gives you some really good information. And it'll also go through here and it will give me the EEV step. EED, indoor unit EXV status, 16. So that one's a little trickier too, so let me point that out. We've seen in here we're way up in the 300s. My math is horrible, okay? I only have a 2-digit display there. I can't give you the full step. So it is 1 to 20, meaning you got to bust out the calculator. 16 times 24 equals 384 steps. That's what that controller is telling you. It don't tell you the actual step like this one will tell you. Hold on. I'm trying to go through it too fast instead of. All right, so I'm going to that status view of indoor unit. This one's at 414. Unit number 3 is at 325. So
That's right where
it's
that
close.
was. Yeah.
It's close. And it doesn't need to be exact. What I'm telling you guys is, for troubleshooting purposes, you don't need to be that perfect. All we want to know is that VEV wide open? Is it not wide open? All I'm trying to tell you guys is the service tool gives you what you need to know to figure out what's going on with that machine. You don't have to hook gauges up to it. You don't have to hook up, you don't have to do a whole bunch of thermistor readings and stuff like that. You can go to the indoor unit status and look at the indoor ambient, and if it says it's 68 degrees, is it 68 degrees? If it's not 68 degrees, if it's 85 degrees in there, then we need to dig into that indoor ambient thermistor, right?
Right. Oh yeah. And think how much time this can save you. You know, these jobs can be real big with tons of several indoor units. You don't have to go to every indoor unit to get these readings. You can just hook up to any unit and get every single reading you need.
Now we say any unit, any MultiPRO unit.
Correct.
Just be careful here.
Any MultiPRO unit. Yes.
All right, welcome back, everyone. Hope you enjoyed that video of showing you how the refrigerant flow goes on the MultiPRO system versus a multi-zone system, and understanding, how they work, to understand more how you troubleshoot them, and then the service tool and the great information that service tool gives to you. Like I said before, and I've said multiple times, I think that service tool is worth every penny. It just makes troubleshooting that unit so much easier. Not only can you troubleshoot the unit, but you can actually drive the system from there. So whatever indoor unit or outdoor unit you're standing next to and you're hooked up to, you can drive the whole system from right there, and you can run all your diagnostics, try to figure out what's giving you the problem with that unit. So I want to give a shout out again, though, like I said, in the upcoming trainings on the 29th and the 30th, we're going to do a live startup of the MultiPRO system down in our Atlanta lab. That will be live. So if you haven't registered for those, make sure you register for that 29th, and we'll do that live startup of that machine. And then on the 30th, it'll be more of the same type of thing. We're going to run through some diagnostics and stuff like that. We do live Q&A with those. So, if there's things that you want me to try while we're on that broadcast, you can ask the question. You can see if we can duplicate what you got going on there. Just keep in mind that it is a lab, so we don't have design load conditions. Our indoor units and our outdoor units are in the same room, so it's not really loaded up equipment like it would be out in the field, but you can still get a gist of how the tools and stuff are used. So anyway, that's coming up on the 29th and the 30th. And as far as this broadcast goes, once this broadcast is over, it will be reposted on our YouTube channel, so you'll be able to look that up. All right. So, Jesus, I think we should jump back into questions. What do you think?
Yeah, no, for sure. I definitely agree. So we got a couple more come in. So we got asked, this is for a R32 multi-zone, multi-24 HP. The product data states pipe length min-max is 10 to 197 feet. Is that length combined for all zones connected or individual zones?
No, it's combined. It's total pipe length.
Okay. Well, that answers that. And the next one Steve had, he was asking, is the service tool available and at what price? And I'll go ahead and answer that. So just reach out to your nearest distributor or your most favorite distributor and just see if they can quote you out the tool. If they don't have it in stock, they can obviously inquire about it to us, and we can just tell them whatever the price is, and they'll be able to relay that over back to you.
Well, let's also go ahead and pull that up on the website where we have those tools listed. So if you go to greecomfort.com and you go underneath that contractor tab, and you'll see GREE Service Tools right there. You click on that. And then if you scroll down a little bit, there's a video about it, which is pretty cool, on the single zone service tool. You guys can watch that video. Anyway, also it's a promotion. So if you go down a little bit, I want to kind of talk to this just a little bit. In our last Tech90 that we did, which again, you can go to greecomfort.com and you can go to our videos from there, or you can go to YouTube and type in greecomfort.com. You will find the last Tech90 we just did last month. And it was all about these service tools. We talked about them. There's a good one on the single zone service tool. Now, what I wanted to tell you guys is on the single zone service tool versus the multi-zone service tool for the mini split line, MultiPRO has its own specific service tool. But on the mini splits, we have a single zone and we have a multi-zone. And we talk about this in the video. But just so you know, the multi-zone service tester, when you hook up to that, you hook that up to the outdoor unit, there's a plug-in on the board you plug it up to, and you can run full diagnostics and analyzation on that machine of the outdoor unit and all of the indoor unit run data. You toggle through whichever indoor unit you want to look at. Say you've got 4 indoor units, you can toggle through the parameters of each indoor unit through that multi-zone service tool, which is a pretty neat tool. But the single zone service tool, even though it says single zone, can also be used on the multi-zone. I want to make sure everybody's aware of that, and it can also be used to help you with E6 communication error troubleshooting, whether it's on a single zone or a multi-zone. So if I was going to choose between one of the two tools, because I don't want to have to buy both, my recommendation to you would be buy the single zone. Just remember, when you're running data, you're only going to see the indoor unit for the port you're connected to. And the way GREE labels their ports, are labeled A, B, C, D, so on, depending on how many indoor units you have. So if I'm connected to the A zone, I'm only going to see the outdoor unit information and the A indoor unit information. Then if I move the wiring to the B zone, then I see the outdoor unit information and the B zone indoor information. So, but keep that in mind. But that service tool will actually work on both single zone and multi-zone. So I just want to make sure everybody was aware of that. As far as pricing goes, as Jesus said, you need to reach out to your distributor, because, you know, we only sell to the distributor sells to you guys. So we can't possibly give you pricing. You got to get that through your distributor. So, all right, Jesus, what other kind of questions we got hanging in there?
I think for the most part, I think we're pretty much updated and up to par with. Oh no, actually, here goes. We got a flex question. Here we go. So on the flex units, what is the adapted mode switch, and why is it undocumented?
So that's actually been, as far as I know, it's been updated in the service manual. Jesus, do you know more about that?
I'm not sure if it's been updated or not. We can, let's see. No, honestly, at the time right now, I'm not really sure.
Okay, I believe it's been added to the quick start guide. But regardless, Steve, we've got your email here. We can get back to you on that and give you more information. I'm just not, I don't keep up with the flex units as much as I do the MultiPRO system, so we will get you an answer.
Yep, sure will. And like you stated, we have his email, so we'll reach out to him, let him know exactly what that is.
So I want to kind of double back to Mark, this next question. So I don't want to get into full detail, but basically I was understanding is he's got concerns about R32 refrigerant versus 454B and using equipment for 454B. And the longevity of R32, how long it's been around. So, you know, I don't want to go into great detail because this broadcast is more about MultiPRO. But R32 refrigerant has been used in other countries for a better part of 10 to 12 years. That refrigerant's not going anywhere. It's going to be around for a long time. R54B, that was developed just recently and has not been wildly worldwide used or used near to the extent of R32 equipment. R32 equipment's been installed and been functional in other countries, like I said, for 10, 12 years. R454B cannot claim that. They don't have that. That was developed as a new refrigerant to take the place of 410A. So I'm not trying to cut it down. I'm just saying R32 does have real world experience of equipment being installed and functional versus 454B does not, right? It is what it is. So that refrigerant is not going anywhere. And then also when it comes to 410A, 50% of 410A was R32 to begin with. Now it's just going to be 100%. So a big portion of 410A was already R32. So, but anyway, to give you a little more comfortability to it, if you go to YouTube and type in greecomfort.com and R32, you will see we have a host of different videos talking about that refrigerant. So I would encourage you to go take a look at that. Yeah, there you go. Whole bunch of different videos where we've talked about R32 refrigerant. So, and there's a host of other manufacturers and stuff like that are also using R32. There's a lot of videos about R32 out there. So I would encourage you to go watch some of those videos. Anything you want to add, Jesus?
Yeah, regarding the R32, and it's like as Greg stated, it's been around for better yet of what 10, 15 years, overseas, and it actually comes from the originators of that refrigerant are from an actual manufacturer, which is obviously our competitor. But I mean, what I'm getting at is, it's not a refrigerant that was developed by, like, for instance, a chemical company. It was an actual manufacturer that developed that. They've since released that patent, so it gives you a little bit more comfortability of, well, you know what, an actual manufacturer made this, and they tested it in their systems, and they also used it in their systems. So it's just something to double down on the R32 and its presence in the field now and in the past.
Yep. Well, the one thing I can tell you is that, and I don't know this for sure, but so the refrigerant leak detection that is required on R454B or R32 units installed in the United States, that's U.S. government that is mandating that. Okay. What I'm getting at is the R32 products used in other countries, I don't believe have any kind of refrigerant leak detection or anything else. And there is no, that I know of, any horror stories about it because it was a mildly flammable refrigerant and catastrophic things happening because they had a leak or whatever. And the machine didn't have any way of notifying people that it was leaking refrigerant, right? So, so not only has it been used for a long time, it's been used for a long time, and they don't have the refrigerant alarms and stuff that the U.S. government is mandating that this equipment have. So that should give you a lot more comfortability to it. It is mildly flammable. And I've done a video on that as well. That refrigerant will not burn without direct flame added to it. As soon as you take the flame away from the refrigerant gas, it quits burning.
Right.
So it's not, it's nothing like propane or anything else. It's actual flammable gas, right? So
Well, it's also double down on the R32 and its characteristics of what it's made of. It's really the safer refrigerant. I gotta go as far as saying that just because it doesn't contain any PFAS. Look up that chemical. It's the forever chemical, which is inside the R454B refrigerant. So just like I said, just look it up, and you'll see exactly what it is and what I'm talking about. And pretty much to add to that, you need actually less refrigerant when it comes to R32 to do the same or more cooling effect when it comes to air conditioning. So just a couple other facts that pretty much say that R32 I would say it's king, honestly.
Well, from there, we'll let them do their own research.
Right, exactly.
Right?
Yep.
Kind of like what we've done and read about it and stuff like that. So,
Right.
And we don't want to form your opinion for you. You need to go look at the stuff yourself and form your own opinion of what you think, of R32 versus 454B. Those are two refrigerants in central air conditioning in the United States that you get to choose from now. So, anyway, any more questions coming in?
Let's see. Let me do this up there. I believe that is it. We're up to date on the questions.
Awesome. All right. So, as a reminder, don't forget, November 5th, we'll have another Talking Comfort Live. And then October 29th and October 30th, we'll have the live broadcast on MultiPRO equipment down there. So, and like I said, with the time of the scheduling and everything, I didn't know I was going to be installing the heat kit and everything down there in Atlanta. So we'll make sure we get some good video capture of that. We'll talk about installing the heat kits and showing the functionality of that. Also the startup of the machine. And then, like I said, we do those in 2-hour broadcasts, so we don't take too much time out of your guys' day. So there's going to be back-to-back 2-hour live broadcast. So one will be more about commissioning and startup of the equipment. The second day will be more about run testing it and the service tool and how's the machine run and stuff like that. And hopefully maybe I can try to put a few bugs and stuff into it and show it actually in some faults. So anyway, and then like I said, whatever suggestions you guys have, the live Q&A. It doesn't have to be a question. You can say, hey, could you see what it does when the machine does this or that? And we can maybe do some of that as well. So, all right. Hey, Seuss, you got anything else to add?
No, I mean, I just want to, show gratitude to our audience. They tune in and they really listen to us, and we do really try and give y'all the information that y'all need, that y'all looking for, and, kind of give y'all a better, I guess, to be more comfortable to be able to work on mini splits, on, multi-pro systems, even commercial VRF. So
that's right. Well, with that, I know we ran a little late. Sorry about that, but we appreciate you tuning in, and we'll see you next time. And remember, agree,
we're by your side.